Hi, St. Barnabas. This is Mrs. Lafferty again. I know Mrs. Snyder misses you, and I miss you guys too, so she's letting me help. This is Lesson 90, Reducing Fractions. It's part 2, so you must have had a little bit of that already. So we'll see if we can learn a little bit more about it. Okay, we're going to skip that part. I'm going to go right to the new concept. So it says the equivalent fractions, pictures below, name the same amount. So we know that. We know that a half is also a half, but you can cut it into extra pieces and make it into 4/8, right? So 1/2 is equivalent to 4/8. We know that. What if I wanted to reduce that 4/8 to lowest term? So take 4/8 and change it into a half. How do I do that? So that's what we're going to talk about today. Let's review a little bit. So I'm going to put that aside for just a minute. Come over here. First of all, we need to know what a factor is. So remember that a factor is a number that when you multiply with another produces a product. So the factors of 6, 1 and 6, 3 and 2. So it's two numbers that make up a product. So we're going to need to know that, and we're going to learn about the greatest common factor. Okay? So let's say I have 8 and 12. I have two numbers, and I want to find the factors of 8. So what two numbers can I make when I multiply will equal 8? 1 times 8, right? So that's a factor of 8, and that's a factor of 8. 2 and 4. 2 times 4 is 8, right? So those are factors. And I can write them in pairs, or I can write them as a list. Either way, whatever way works best for you. Sometimes you can write the 1 over here and then the 8 way over here, and then fill in the middle if you want to. But always remember to write your 1 times that number, because 8 is a factor of 8. Okay? So factors of 12. So 1 and 12, 2 and 6, 3 and 4. Or I can write 1, 2, 3, 4, 6, 12. Either way. Okay, so I want to find the greatest common factor. So let's think about what that means. Greatest, biggest. Common means they share the same number. And factor. Now we know what a factor is. So the greatest common factor of 8 and 12. So I'm going to write my 8, write my list. 1, 2, 4, 8. 12, 1, 2, 3, 4, 6, 12. So what's the biggest number that they have in common? It's 4, right? Okay, so the GCF, or the greatest common factor of 8 and 12 is 4. Okay, so now we're going to use that idea to reduce fractions. So example 1 says, there are 4 blue marbles and 8 white marbles in a bag. If one marble is taken from the bag without looking, what's the probability that the marble selected is white? They're tricking us because they're using probability and fractions. Yikes, but we can do this, okay? So we're saying out of these, how many blue marbles out of the total, right? How many white marbles out of the total? So they're asking for the probability that the marble is selected is white. So we have 8 out of 12. There's our fraction, 8 out of 12, right? And they're going to say, oh, both those numbers are even. So I'm going to divide by 2, top and the bottom, get 4/6. Divide by 2 again, get 2/3. And then they tell you we can use the greatest common factor, and that's what we're going to do. You can get there this way. If you have a really big number, sometimes it helps to make it smaller before you try to find the greatest common factor. So it's not a killer deal if you don't find the greatest common factor, but you do have to remember your divisibility rules, and I'll put those on the website. So back to our problem. To reduce fractions, divide by the greatest common factor. Divide the numerator, which is top number, and the denominator, the bottom number, by the same number. So 8/12 divided by 4/4 is 2/3. So 8 divided by 4 is 2. 12 divided by 4 is 3. So if I want to reduce 8/12 to the lowest terms, simplest terms, I'm going to get 2/3. So pause for a minute. Again, it's not critical that you understand this part, but this is why it works. This is the same thing as 1, isn't it? Anything over itself. If I have 4 pieces out of 4 pieces, I have one whole thing. Anytime I divide by 1, I'm going to get the same answer, right? 4 divided by 1 is 4. 6 divided by 1 is 6. 99 divided by 99 divided by 1 is 99. Cow divided by cow is cow. Not really, but you know what I mean. So 8/12 divided by 1, but in that form, is the same thing, but just without as many cuts. Okay? So that's my little format that I like to use. I put a line for my fraction. I put my division. I put a box with a line in it so I remember that those are the same numbers, equals my new fraction. So line divide box equals line. And you don't have to do it that way, but it works for me, and it gives me a good format. Okay, so let's do example 2. Again, they're throwing something tricky at us. They're doing percents, so we got to think about what that means just a minute. Remember, a percent means out of 100. So 40% means 40 out of 100, or I can write it this way, 40 out of 100. 40 divided by 100. 40 hundredths. Say that a bunch of different ways, but it's all the same amount. So they're going to say in their problem, what's a common factor of 40 and 100? Since they both end in 0, I know they both have a factor of 10. Okay, that's good. I could do that. There's probably a greatest common factor, probably a bigger factor, but that's an easy factor. So let's go ahead and divide by 10. Okay, so remember I put my fraction here, put my division, put my box for my new number with the same on the top and the bottom. So 40 divided by 10 is 4. 100 divided by 10 is 10. So I get 4/10. So, I look at that fraction, I say, is that in simplest terms? No, because they're both even numbers, aren't they? So if they're both even numbers, I know I can divide by 2. They both have a factor of 2. So 2 can go into 4 evenly, and 2 can go into 10 evenly, or to get a whole number. So 4 divided by 2 is 2. 10 divided by 2 is 5. So now 2/5. I have my simplest terms, or lowest terms, right? Well, you know, one thing I thought about telling you guys, why does it, when you divide fractions, usually you keep, switch, flip, right? So does it even matter? Because I don't have to flip them, do I? Same number. So don't have to do that. I think that's it. Email me if you have any questions. I'll put my email address on the website on the homepage. Email Mrs. Snyder. She's got some stuff going on, so I might answer more quickly because I'm stuck here at home by myself. She's got family there. But anyway, I'd love to hear from you, and I will do this again tomorrow.